the height of column is equal to 8 meter, the section is square section 50 multiplied with 50 centimeter, and apply horizontal force at the top of column is 50 kilonewton, and the vertical force with eccentricity vertical force is 1000 kilonewton, and the eccentricity at the top of column is 0.2 meter. In this parameter for the service. Now you can read with further information about section and parameter, about the square section, double symmetry reinforcement, concrete strength, strength, high strength, 90 cylinder, and SCD is concrete strength multiplied with 0.85 for the UK national average, and divide by 1.5 is equal to 51. ECM according to Euro code, and ECD is equal to ECM over 1.2. So the value of ECD for design is equal to 36,666 kilonewton per square meter. For this load is for the quasi-permanent load. The solution according to the Euro code, you can use the LCD multiplied with EC, and we calculate for the thickness of the rebar in the section, and we can compute the value of the section to calculate for the EI for the final thickness of the member is equal to 8.60 multiplied to 10 power 13 Newton per square millimeter. This is the critical load, NB, or in the strength Euler formula, or critical load factor Euler critical load is equal to pi square multiplied with I over L square. EI is the value of final of the EI calculated from the ECD, EC, ES, and EF. Combine all the thickness of the member of the concrete with the thickness of the rebar in the section. For the critical load is equal to 3,312 kilonewton. Now let's calculate deflection. You can check on my previous tutorial about how to calculate it manually. For data, you can calculate it based on the horizontal force and eccentricity from the axial force. The formula for the displacement of the horizontal force, and the formula for displacement made from the axial force with eccentricity E. So after we input the value of NED 1000 is eccentricity 0.2 and convert it to the correct unit, we got the answer. The deflection made by the vertical load and with eccentricity is equal to 74.4, and for the horizontal force is 99.2 millimeter. Now let's check about displacement due to geometric inflection. As we discussed about the inflection, you can use two options for the calculate for the global inflection. The first one, use specific formula, and the second one, use the notional load. We will use the formula and compare each other in the example. Now let's come back to check about the example. And displacement show the geometric inflection. We focus about the global inflection now. Phi is equal to phi0 multiplied with alpha h multiplied with alpha m. Phi0 the recommendation value is 0.005 ratio, and alpha m, when you input m is equal to 1, is the column in bay for single column, or for the cantilever column is 1. So alpha m is equal 1. And alpha h 2 over square root of h, the value is equal to 0.7071. So after you calculate phi0, alpha m, alpha h, now we get the value of phi is equal to 0.00354. For the displacement, this angle phi multiplied with h is equal to 28.28 millimeter. For the displacement due to imperfection of the global system is equal to 28.28 millimeter for the cantilever column. Now continue to displacement due to geometric inflection. S is equal NED multiply h power 3 over 3 EI multiply with phi. This one is phi. We calculate the inclination due to geometric inflection. And after you input the value, we got S is equal to 6.9 millimeter. This is the value of the geometric imperfection. Okay. Now let's check about the critical load. NB is equal to 3,312 kilonewton. Can check about in about slide about solution according to the 0.2 procedure. And B is equal to 3312 kilonewton. And now let's check for the amplification factor is equal to 1 over 1 minus NED over NB. N is equal to 1 over 1 minus NED. The ultimate load is equal to 1000 over the critical load is 3312. So the final we got the displacement amplification is equal to 1.43. For the total physical displacement is equal to the 74.4. The displacement due to the vertical load with eccentricity, and 99.2 is the horizontal displacement, or lateral displacement due to the horizontal load ED. And 6.9 millimeter is the global inflection. Global inflection is equal to 6.9 millimeter. After we got the value for the lateral deflection due to load with eccentricity, and deflection due to global inflection, you multiply all the value with the amplification 1.43. So it's equal to 254 millimeter. You can calculate the total moment at base, include the first order and second order. Now is equal to the 50 multiplied 8 is the horizontal force multiplied with the column height, and 100 kilonewton is the vertical load, and 0.2 is the eccentricity E, minus 0.02822 is the imperfection due to the geometric imperfection, and the 0.258 is the total flexural displacement multiplied with the amplification. So the final moment at the base is equal to 886.28 kilonewton meter. Now let's check and compare with the GED kinetic advantage. In the case, you can compare, you can use the notional load 0.8 notional load 0.3% multiplied with the 1 Now let's check in the case the n is equal to 1000. Now I input the incorrect. Now we have to check it again about how to apply notional load. You can check it now. Calculator 0.3% or 1000, not 112 or not 102, not 1200 kilonewton. This one is 1000, so we got 3. Okay, now we have to correct the value. If 3 multiplied with 8 is 24. Okay, for the notional load you can apply 24, and for the global inflection, in case you can apply for notional load or for the global inflection. If we apply for the global inflection, this moment due to global inflection is equal to 28.28. We round it down to only 28 at the top of the column. The column with eccentricity is 0.2. So you have two options for the P data. For the big P data, you can apply notional load, or you can apply a global inflection. This is the specific formula. In the case we apply the global inflection in the cantilever column. This is the concrete section and material property. In the kinetic advantage, we model the square section 50 multiplied with 50 concrete strength and modify thickness. We use RE is equal to 0.7 according to the recommendation of Europe code. The effective thickness RE is equal to 2/3 of the RE. And this type of analysis we use nonlinear analysis with light displacement, and buckling analysis we will perform the buckling analysis. One is either this is the concrete strength, 2 section, and 3 modified section, and 4 nonlinear load case, amplifier, and buckling analysis. This one is the important part. We have to assign the mesh with the mesh size. You can input the mesh with the number of mesh or input the mesh size. In this case, I use a mesh size by the input 0.1, or you can input 0.4, 0.5 or 1 meter. To get more accurate result, you have to input a smaller mesh size according to your computer. Based on your computer, if your computer can perform smaller mesh, you can input a smaller mesh, or you can input the mesh size is equal to width of the column to get more accurate result. And after run analysis, we get the displacement at the top is 11.95 or 12 centimeter, and in GAD, after you run nonlinear analysis and with the buckling analysis, you can output the critical load by click on the generate report on table result, generalize buckling, and output the critical magnification factor. This is the visual magnification factor of the cantilever column is 6.02, and this is the total moment at the base is 749.1 kilonewton meter. We indicate we use a nonlinear analysis with a light displacement. We get the result, and after get the result, we can multiply with the amplification factor is equal to 6.02 over 6.02 minus 1 is equal to 1.1992. So we multiply with 1.1992. We got the final moment, or the total moment include for order and second order is equal to 898.323 kilonewton. Now let's compare with manual analysis and FEM analysis using a critic event design 2022. We review in the critic event design 23 is the same result. The total moment at the back by using manual analysis is equal to 886.28 kilonewton met, and the total moment at the back after we use FEM software is equal to 898.32. We use mesh size is equal to 0.1 millimeter, 0.1 meter. Now let's jump into the critic event design. This is the rear model. The rear model we apply for the cross section. The cross section is 50 centimeters square, and concrete strength we include the eccentricity Z1, Z2, and consider for FEM. Take this option to consider the eccentricity for analysis and design. And load, we apply the load on the load. 50 is either horizontal force, and 1000 is the vertical force, and by 28 kilonewton met is the moment due to inflection or the global inflection. And in the load case, we use nonlinear analysis can check about nonlinear analysis with light displacement and general light backlink. After that, you can run analysis. Now let's check displacement. When you critique about design 2023, the result is almost the same with version 22. You can check in my slide. This is the result using critique about design 22, 11.95. This result is 120 millimeter, is the same. And for the force, click on the amplify. For the moment, the maximum moment is 749.1. That is correct. Now let our output the result of the critical magnification factor table result. General light backlink. Click on the critical magnification factor. Generate. The value of magnification factor is 6.02. 6.02. You can input this value to calculate for the amplification factor. Is equal to 6.02 over 6.02 minus 1 is equal to 1.19. So you take the moment 749.1, 749.1. This is the moment, and by this is the amplification factor. So the total moment is equal to amplification factor multiplied with the nonlinear moment, 899.32. Okay, 899. Now the result is 98. Okay, 98.32 is correct. This is how you can use manual analysis compare with the FEM design. You can check one step by one step in my tutorial. If you don't know clearly about the concept, you can comment in my YouTube channel to ask me more. I will make another tutorial to clarify about the topic. And thank you for your watching. Thank you for your watching. I hope you enjoy the tutorial and gain your knowledge from day to day.